There are a couple other things that we have to discuss when we discuss conditions. So this is a condition, and one of them is the not operator. So this is similar to the one that we did when we did the and operator. Okay, but say we wanted this person, we just want to error check them. So if they don't enter a number between 1 and 10, we want to tell them to enter the correct number. So what we could do is put a not before it. So this is the condition that says if a number is between 1 and 10, it'll be true. But if I put the not before it, it is now if it's false. So if it is not the case, that symbol right there is if it is not the case, then do whatever this is true. Okay, whatever we do. So system that out. Okay, try again. And what we could do is actually give them the chance to try again. So this is another way to error check. Remember, don't redeclare anything, but we can just do that. Okay, so first thing you have to notice by this is that anytime you have a condition, so you've probably figured this out already through programs and things like that, you need to have parentheses surrounding the whole thing. Doesn't matter what the condition is, there has to be parentheses. I don't technically need these, but I do because I want them to evaluate this full thing first and then do it. So if it's not the case that both of these things are true. If I just put the not on this one, it would mean something completely different. Okay, so just a long name for a thing. So if I put something like 4 in there, nothing's going to happen because it doesn't enter into that. But if I enter in an incorrect value, like 99, try again, it's going to ask me to do it again. Now when we get to loops, we'll have them able to try over and over again if people can't seem to ever get that number between 1 and 10. Okay, but this is the not operator. So you put it anywhere that you want to change. Now change the truth value of it. So if I put the not on this, if this is true, the not makes it false, and vice versa. Now there's something called DeMorgan's law, and we can make an equivalent statement to this. DeMorgan's law says I can basically distribute this negative through to all the pieces and it will have the same truth value. So in other words, I'm going to create this exact same thing again down here, but I'm going to change the condition but make it the exact same condition. Okay, so the following code works exactly the same as the above code. Okay, so in other words, we're giving these people a second chance. If they get it wrong here, they'll get it wrong again. Or, we'll give them another chance. It's almost like a loop. Okay, we distribute this negative through. So what we do is actually take this thing and move the not on the inside. So I'm just putting parentheses around this whole thing so it doesn't try to do not num. And I do the same thing here. I put parentheses around this whole thing and put the not in front of it. Now because I've done this and I moved the not to the inside, I no longer need these guys out here because I have it's too many. So I have, if this is true, this not is going to make it false. If this is true, this not is going to make it false. So when I do that, I also have to change this to an or. And that's DeMorgan's law. I don't know if you remember this from, I don't know if they teach this anymore, but when you distribute that negative through, if this is false, this becomes false. It wouldn't make it an and anymore. It makes it an or if we want the condition to remain true. Okay, so we want the condition to remain exactly the same truth value as this one. So this one and this one are still exactly the same. Okay, because we changed the truth value of all of these pieces. So if you don't believe me, let's try it again. It's taking forever for me. Okay, so this is the very first time they ask us to enter, so I'm going to pick a bad number. 117. Ask me to try again. This is the first truth value. It is not the case with the and, so I'll try 15. Doesn't like that either. So as you can see, we only had 2. These 2, this one and this one, are exactly the same. Now you could make this even more and distribute this negative sign in here. If I try to change this thing, it changes the truth value. So it would be, it is not the case that num is less than or equal to 10. So if it is not the case, so let's do this one more time and make it another exactly the same thing. What the hell did I just do? I made a square root symbol. Okay, so this following code is going to work exactly the same. I can actually take this and distribute that in. So if I take that not and distribute that in, it takes the not off this into this, and it just makes it greater than. So the opposite of less than and equal to is greater than. Same deal here. This is greater than or equal to, so the opposite of that, getting rid of this, would just be less than. This might take a little practice, or you might get it right away. Doesn't matter, as long as you get it and you try it. Okay, so these 3 things, based on De Morgan's law, are exactly the same.